2-1, solving one-step equations. In this section, we are going to solve one-step equations in one variable. And our essential understanding is that equivalent equations are equations that have the same solutions. You can find the solution of a one-step equation using the properties of equality and inverse operations to write simpler equivalent equation or equations. So what we're going to start to do in this chapter is we are going to solve all sorts of different equations. And we start with the simplest ones. We start with one-step equations. So we're going to use our basic properties of addition and subtraction in order to get equivalent equations that will help us get answers to equations. So my addition property of equality says that adding the same number to each side of an equation produces an equivalent equation, which means if I start with A is equal to B, if I add C to one side, I have to add C to the other side. Okay, we're talking about both sides of the equal sign, right? So as long as I do the same thing to both sides in an equation, I keep the equation balanced, right? That's algebra's golden rule. Whatever you do to one side, you must do to the other side. Okay, we can see that with subtraction as well. So subtracting the same number of an equation, subtracting the same number from each side of an equation produces an equivalent equation. So again, if I start with A is equal to B, if I subtract C to one side, I have to subtract 3C from the other side. And we can see that here with the example, subtracting 3 and subtracting 3. Okay. The way I decide what to do when I'm solving an equation is the important part. Okay. So to solve an equation, you must isolate the variable. You must get the variable by itself. So you do this by getting the variable with a coefficient of 1. That's important because if it doesn't have a coefficient of 1, we don't have the solution yet. So we get the variable with a coefficient of 1 alone on one side of the equation. Doesn't matter which side. Typically, most people like to put the variable on the left, but it doesn't matter. We can isolate a variable using the properties of equality and inverse operations. An inverse operation undoes another operation. For example, subtraction is the inverse of addition. When you solve an equation, each inverse operation you perform should produce a simpler equivalent equation. So what we're going to be doing is we're basically going to be doing opposite operations until we can get down to an equation that is as simple as it possibly gets. Let's take a look. So problem 1. What is my solution of x plus 13 is equal to 27? So we're solving an equivalent equation using subtraction because I clearly see right here I have addition. Okay? And if I want to undo addition, I use subtraction. Okay? And mostly when we do equations, we like to do a top-down approach. So we start with our equation right here in our top row, and we're going to work down, making each equation simpler and simpler so I can see the steps that are going to be going on. Okay, so I see x plus 13. There's my variable right there. I want to get that by itself, which means I need everything else away from it. Okay, everything else on that left side of the equation has to be gone. So I see this plus 13. I'm going to subtract 13 because subtraction undoes addition. But whatever I do to the left side of the equation, I have to do the same to the right side of the equation. Okay? Then these two cancel, which was the point, giving us x all alone. And a typical thing to do is to bring down anything else that we haven't used. We're going to bring down the equal sign, and now we have an actual calculation that we have to make. 27 minus 13, or 27 plus a negative 13. When I subtract those, I get 14. So x is equal to 14. Now, this is a one-step equation section, so most of our, or all of our equations are pretty much going to be done with one step. But if x was not by itself, we might have to do something else and keep going. Okay? You should also maybe try to check your work to say that if x plus 13 is equal to 27, if I replace my x with my answer, 14, is that true? Well, 14 plus 13 is 27, so that actually checks out. Not something you have to do every time, but it is a good habit to get into for harder questions. Okay? Let's take a look at some Gongora problems. Okay? What is the solution of y plus 2 is equal to negative 6? Okay, so my variable is the y. I want to get it by itself. I have a plus 2, so I want to subtract 2 from both sides. My resulting equation, which is simpler, is going to be y is equal to negative 8. Okay? Now, if perhaps I wasn't sure what to do, and I wanted to try to add 2 to both sides of an equation, you would see that this does not make a simpler equation. This would be y plus 4 is equal to negative 4. Well, that's nice, and that is an equivalent expression, but it's not a simpler one, and it doesn't get us closer to the answer. So make sure that we're always doing the opposite operation when we are trying to solve. Okay? So why does subtracting 13 from both sides of the original equation result in an equivalent equation? Because, and I cleared this off, when I subtract 13 from both sides, right, we still have and x is equal to 14. This is still a similar equation because we're doing the same thing to both sides, okay? So we have an equivalent expression coming from the subtraction property of equality. Okay? So when I subtract the same number from both sides, I get the same expression. With problem 2, now we see our variable on the right side, which is fine, but I also see now that I have a subtraction, b minus 3. Okay? So in order to get b by itself, I want to do the opposite. I want to add 3 to the right side, which means I have to add 3 to the left side. Okay? Those two cancel, which is why we did it to get b by itself. And then negative 7 plus 3 gives me negative 4. Even though b is on the right side, this is still simplified, and my answer is negative 4. Okay? Let's try some Gongora problems. Well, the first one, part A, looks pretty straightforward, right? All we have to do is add 8 to both sides. That gives me m by itself, bring down the equal sign, and 14 plus negative 14 plus 8 is negative 6. Just because there are fractions in part B does not make it terrible, okay? We are still going to do the same process. We're still going to do the same steps. So we're just going to add 3 over 2 to both sides. 1/2 plus 3 over 2 is 4 over 2 is equal to y, which of course can reduce to 2. Okay? So don't be intimidated by fractions. The process that we are going to do is going to be the same. Okay? Look to get the variable by itself by doing inverse operations. Inverse of addition is subtraction. Inverse of subtraction is addition. We can do the same thing with multiplication and division properties of equality. Okay? Division is the inverse of multiplication. And if we look at my properties of equality, the first one, multiplication, says multiplying each side of an equation by the same non-zero number produces the equivalent equation. This is important, non-zero, because if I multiply an equation by 0, if I multiply anything by 0, I'm just going to get 0. So that doesn't help me solve anything. Okay, so we're always going to be multiplying by non-zero numbers. And my property is the same. A is equal to B. If we multiply one side by c, we have to multiply the other side by c, with the expectation of getting something to cancel. Okay? Division property of equality says the same thing. Dividing each side of an equation by the same non-zero number produces an equivalent equation. And same thing here, non-zero, because I can't divide by 0. That is undefined. So that's why we have this caveat right there that says c cannot be equal to 0. So then if I divide one side by c, I have to divide the other side by c to keep both sides balanced. Usually we do this so that something will cancel, so that something will reduce. Okay? And sometimes my numbers aren't even perfect. They're not even very nice. Just remember that 4x is equal to 64. This 4x right there means 4 times x. Okay? So when I see this, I want to get x. Same thing, I want to isolate my variable by doing inverse operations. I see multiplication. The inverse of multiplication is division. So I'm going to divide both sides by 4. And we're typically, with this top-down notation, going to use this fraction notation as opposed to a division sign. When we calculate this on my calculator, I get x is equal to 1.6. If I want to check it, I could check it, but it will work. Let's try some guided problems. Now, something to think about as we look at this first one, part A, okay? I want to get x by itself, so I'm going to divide both sides by 15. That will cancel these two and give me that x is by itself, and it will give me 10 over 15, or 2 over 3. Whoops. 2 over 3. However, another way to think about this, if we want to, is that we could always, division is the same thing as multiplying by a fraction. So we can also do that as well. I could take this whole equation and multiply it by 1 over 15. Those two will still cancel, and as long as I do the same thing to both sides, ran out of space a little bit there, I still get that x is equal to 2/3. And remember that this expression, x over 15, is the same thing as 1 over 15 times x. Okay? So multiplying by 1 over 15 is the same thing as dividing by 15. Okay? So when we have these fractional expressions, they shouldn't be terribly confusing. Part B is a little simpler, and we can just use a calculator to get this. We divide both sides by a negative 3.2. And we get that z is equal to 14 divided by negative 3.2 is going to be, let's leave it as a decimal since we have decimals in this problem, negative 4.375. Usually if a calculator, or if a problem has fractions, you should leave it in fractional form. If a problem has decimals, you should leave it in decimal form and get used to being able to go back and forth between both of them. After multiplication comes division. So to solve this equation, and I'm just going to write it over again so I have a little more room. Okay? To solve this equation, which has division, x divided by 4 is equal to negative 9, in order to solve it, I need to multiply both sides by 4. Okay? These two will then cancel out, and we'll have x is equal to negative 36. Okay? So when we see these expressions with a variable divided by something, we are going to clear that something by using multiplication. Some of our guided problems here. Again, all I have to do is to multiply both sides by 3. And my answer becomes that 57 is equal to r. That's my equivalent expression. The 3's cancel each other out. And we're left with r is equal, or 57 is equal to r. Same thing for part B. I'm just going to multiply both sides by negative 9. Here they cancel out. X is going to be equal to negative 72. 8 times a negative 9, negative number. Okay? Careful with the signs. Careful that we're not making any weird mistakes. Okay? When the coefficient of a variable in an equation is a fraction, we can also use the reciprocal of that fraction to solve the equation. Much easier than doing two separate steps, one multiplication, one division. So the long way of doing this particular problem is to divide both sides by 4, multiply both sides by 5, but there's an easier way to do that. Rewrite it. Okay? So when I look at this problem, I see 4 over 5. If I want to cancel 4 over 5, I can multiply both sides by the reciprocal. So I can multiply both sides by 5 over 4. So the 5's cancel, the 4's cancel, and we're left with m is equal to 28 times 5 over 4. Now, hopefully we remember how fractions work. That 28, we can think of that as 28 over 1 times 5 over 4. And the easiest way to simplify a fraction is to cancel things that are on the bottom with things that are on the top. So this 4 and this 28 can reduce to 7 over 1, which then turns this into 7 over 1 times 5 over 1, which is just 35. Okay? Anytime we're working with fractions, it is always better to reduce first before multiplication. If we wanted to, we can do 28 times 5, take that answer, divide it by 4, or 28 divided by 4 first, and then multiply that answer by 5. We could do that, but it's nice to see it in fractional notation so you can see what is reducing and what is canceling. Let's try our guided problem. A few. Okay. So what is the solution of 12 is equal to 3 over 4x? So I'm going to do the same thing I did before. I see 3 over 4. I'm going to multiply both sides by 4 over 3, the reciprocal of the coefficient of x. 3's cancel here, 4's cancel here. We're left with x by itself. 4, the 3's can cancel here and turn that into a 4 to give me 16. Or 4 times 12 and take the answer and divide it by 3. Are the equations m is equal to 18 and 2/3 m equal to 12 the same thing? Well, let's see. 2/3 m is equal to 12. If I want to get m by itself, same thing, I multiply by the reciprocal. Okay. This turns into, these two cancel, these two cancel. That's 6, and 6 times 3 is 18. So yes, they are the same. And it's tough to tell that by just looking at it. So we know by actually solving for m and proving that these two are equivalent expressions. Finally, problem 6, we can use a one-step equation as a model. So now we have a word problem. Toucans and blue and yellow macaws are both tropical birds. The length of an average toucan is about 2/3 the length of an average blue and yellow macaw. Toucans are about 24 inches long. What's the length of an average blue and yellow macaw? Well, the length of the toucan, all right, let's break this word problem down. The hardest part about a word problem is relating the words into some sort of math. Okay? So the length of a toucan, so we want the length of the toucan is there's my equal sign, there's what I'm relating, 2/3 the length of the macaw. And the toucans are 24 inches. So we have the length of toucan is 2/3 times the length of macaw. So there's my basic equation. And I know this. I know the length of the toucan. It's 24. So I can say that 24 is equal to 2/3 times the length of the macaw. So if I want to find the length of the macaw, which is what this question is asking, I can do just what I did before and multiply both sides by the reciprocal 3/2, right? Which turns into 36 is equal to the length. So the length of the macaw is 36 inches. Let's set up another one. I got it problem. Online DVD rental company offers gift certificates that you can use to purchase rental plans. You have a gift certificate for 30 bucks. The plan you select costs $5 per month. How many months can you purchase with the gift certificate? This should be pretty obvious, a little bit easier to set up. You have $30. The plan you want to select is going to be $5 per month. So we just solve for x, divide both sides by 5, and we get that we have 6. Okay, so the answer to the question is 6 months. Okay, don't just leave the answer as 6 is equal to x. Make sure you specify what we're actually trying to solve. Okay, so to wrap it up, in our lesson check, we should know how to do all these problems. First one, subtract 7 from each side. Second one, add 4 to both sides. Third one, divide both sides by 5. And in this case, y is going to equal 24/5. It doesn't reduce at all, which is okay. We have already read 117 pages of the book. You are 1/3 of the way through the book. Write and solve an equation to find the number of pages in the book. Well, all I have to do is take 1/3 times the number of pages. And that is going to be equal to 117. Because you are 1/3 of the way through the book, which would give me a total of 351 pages. Okay. Which property would we use? Well, looking carefully at number 5, I would subtract 3 from both sides because 3 is positive. So this is the subtraction property of equality. Number 6 is the division property of equality because I'm going to divide both sides by 2. Number 7 is the addition property of equality because I have x minus 4. So I'm going to subtract 4 from both sides. And finally, 8 is the multiplication property of equality. So, because I have x divided by 7. Write a one-step equation, then write 2 equations that are equivalent to your equation. Well, I can do that pretty easily. So a nice simple one-step equation would be something like x plus 2 is equal to 6. Well, I could actually solve this and say x is equal to 4, and that's a similar equation. Also, I could do something weird to get an equivalent equation, like adding 2 to both sides. Now it says x plus 4 is equal to 8. Those are still all equivalent equations. That one, and this one. They are all equivalent to each other. And I can prove it because I can solve them all, and I'm going to get x minus x is equal to 4 for all of them. Okay? I could even go super crazy and maybe multiply an entire equation by something to get equivalent expressions. And we'll deal with that a little bit in the next section. And that is 2-1, solving one-step equations.